Today we're going to focus on a little bit of blueprint reading. We'll go through the blueprints on Mara's machine. It's actually a MA3200 2 series. So down here it'll tell you how many pages are on the print itself, the page number, the machine type, the description of what it is, so the first page is a catalog page. What the catalog page is a list of all the elements that are in the drawings with the page numbers. So for example, if you want to look at the heater band circuits, it would be on page 13. And the way these prints are laid out, it's in a grid format. So you have A to U, sorry, and 0 to 11. So anytime you see a reference, you just use the grid. It's like a mapping type of format. You can use just the grids as finding your location of where your component that you're looking for is. Page 4 is an overview of where all the switches are. So if you don't know where there's a switch, you can just go to page 4 and it'll lay it out. So you have your lights here, your light stack, S277, S205. This is a transducer. You have S202, S100, and again the R4 is another transducer for the carriage. You have R1, S103, etc. And again, the bottom section is the backs of the machine layout. On page 5, we have a drawing of the elements for all the heater bands. So in this case, there's 5 heater bands. Each zone from zone 2 to zone 5 contains 4 heater bands per zone. Actually, sorry, zone 3 to 5. Keep in mind that zone 1 is at 220 volts, and zone 2 to 5 is 480 volts. This is page 6, and this is the cabinet layout. So again, if you're looking for a component, you can come to this layout and look where the different components are located. And page 7 is the middle cabinet layout for the SSRs and all the breakers and fuses, and your 2 transformers. And page 8 is the KEB layout. And so we begin at page 9. Page 9 is the first page of the actual drawings. And so you'll see line 1, line 2, line 3. And that goes to Q100, which is the disconnect on the front of the machine. And that's a 160 amp disconnect. And this little guy, the U, is the shunt breaker, which is on the high side of the machine. Again, anytime you're working inside the cabinet, make sure that you don't touch X7. X7 is always live, even with the power off, because this X7 terminal block controls the shunt breaker. And that's on the live side of the power. From there, we go to the pump motor 1. the assistant power sockets in the back of the machine, your heater circuit, your central loop motor, your cooling circuits, and your 220 volt power supply. To find out where these are located, it would be on page 10. B2 is the grid number. Following it over to the power supply end, it's American wire gauge 18. You're using wires R and T, and they're black wires. Goes to Q121, which is the 6 amp breaker. And that goes to this T1 transformer, which is a 100-watt transformer. It takes the power, converts it to 220, 110, and this is the neutral. The 110 is used to control the power supplies for the 24 volt. The 220, that's going to be used to control the nozzle temperature and the fans on the system. So let's go to page 15, C0, and we'll see where that leads off. Page 15, C0, and you'll see where you're coming from. Page 9, R9, and it's 220 volts. That goes through F150, and that feeds all the fans. And it also, the 110, will feed that power supply. And this goes on to page to 227, page 16, D0, which will in fact come over here. That'll feed page 36, Q8. And it'll come back into this system and go through this, the starters for the motors and the heaters. The KEB circuit comes from, again, page 9, grid 9, G9, F9, and that's line 1, line 2, line 3. That turns into RST because it's going to the drive. And they're using American wire gauge number 4. It's going to Q103, which is a 100 amp disconnect. And it goes into this QM1, which is the motor starter. When you push the drive power, it actually turns and closes those contacts. So it energizes QM1, which closes the contacts. It then goes to this LC1, which is your line filter, and your FR1, which is your frequent, your other filter, and that feeds line 1, line 2, line 3 into the KEB drive. The KEB drive has a couple other options. It has this T1, T2, which is a thermistor. This thermistor keeps track of the temperature of the motor itself. UVW is the power out to the motor. And then you also have a resolver or an encoder, which is connected to DN15. This plus and PB is your brake resistor. J5 or AJ1 control board, that's the card that's getting the control from the pressure sensor that's located on the manifold. So whatever pressure is seen in the system or velocity or flow, it sends that information to this AJ1 card, and that information goes back to the KB drive. This K16 that goes to the safety relay, and that makes sure that if there's a problem with the safety circuit, that the drive will not start. These STO inputs, they also come from the safety relay, and that's when if you have an electric machine, actually it'll tell you that there's a STO, mold close STO, or some other STO error. Unfortunately, on the Mars machines, you do not get the STO errors, but it is caused by the safety circuit not being satisfied. In case people were wondering how these KEB drives work, what it does is it takes a three-phase signal, 60 hertz, this is plus 480, this is minus 480, and this is 0 volts. Sorry for my lousy drawing. And what it does is it actually inverts the signals. So when it goes through the inverter, it takes the negatives and puts them into positives. So the signal going out of the section of the inverter will all have positive values. Then it goes to a rectifying system, which converts it to a DC signal, which makes it a straight line. The DC voltage is the incoming voltage times 1.414, which is a square root of 3. So if you would check the power coming out of the plus plus minus minus, which is your DC bus, you would have 480 volts times 1.414, and that would be a DC voltage. What also happens inside this KEB drive, it also converts the frequency. It raises the frequency and allows the drive to send out a certain frequency. I believe it's 0 to 1000 hertz. And that frequency is what actually makes the motor, the servo motor, rotate. Any questions on this? Okay. The J5 cooling motor. This J5 cooling motor is the only induction motor in this machine. And when you turn on the energize the drive by turning that little pump motor symbol on, it actually energizes this motor and it runs constantly. It has a breaker here. It's Q136, which is a 3 amp breaker. And K12 is actually the circuit that when you hit the drive closes the contacts, so this machine, this motor will start running. The next page is the assistance power sockets. Again, there's 3 sockets on the back of the machine. It's a black box, and it has 3 faceplate covers on it. So it have little square covers with 4 screws, and that is not calculated in the full load amperage of the machine. So if you're to use those, make sure that your amperage going to the machine is adequate enough to handle the 3 sockets that are on the back of the machine. So therefore, you'd have to add 3 13 amp circuits, which is 39 amps extra. Again, they're using American wire gauge 12. You have breaker Q111, 113, and 114. Heater circuit. Again, you have American wire gauge number 8 going into this RST, your heat-on circuit breaker, contactor right here, KH1. So when you push the heater on button, KH1 energizes, closing those contacts. The power then goes through Q122, which is a 6 amp, and that's going through T2 transformer. Again, the T2 transformer is taking the 480 volts and transforming it into 220 volts for the front zone nozzle heater bands. And that's protected by F11, a 6 amp fuse, your SSR, KS1, that's using American wire gauge 14, and you have your 2 nozzle heater bands. Keep in mind that the heater bands are grounded. That presents a problem. Number one is for safety, but if the heater bands ever short out, what happens sometimes is because the power is going to complete a circuit, the heater bands will keep heating up even though the SSRs are not calling for the power. So when you're troubleshooting the heater bands, make sure you know that the heater bands are not shorted out to the side of the heater band itself. The nice thing about these machines is they actually give you the heater band specifications on the bottom of the print. So for example, this has one 42 by 35 millimeter heater band that's 250 watts. And it has one 80 by 48 millimeter heater band, which is 650 watts. Same for zone 2. So you have two 200 by 60, 460 volt, 2200 watt heater bands, and you have one 150 by 75, 460 volts, 1200 watt heater bands. This is a continuation of zones 4 and 5. And here's your power distribution for your 220 volts. I mean, 24 volts, sorry. Again, we already covered the fans. The 110 comes down here to this G2 power supply, which is a 600 watt power supply. And the neutral goes back to neutral. On this power supply, you have something kind of unique that you have to keep in mind when you're troubleshooting the power supply. They call the B positive B. They call C positive C positive. They call B minus B negative minus, and they call C negative C. It's kind of a little odd that should have B plus, C plus, B minus, C minus, but they do not. So what happens here is B circuit feeds all of these pages. C positive feeds these pages. B minus again feeds these pages, and C minus feeds those pages. This is the heater and motor start circuit. So when you turn heater on, it energizes K1, which then activates this contactor, which will close this set of contacts. And that'll turn the drives, energize the drive power. When you do the same for the heater on, it'll energize KH1, which will then keep the heats on. To find out where these solenoids are attached to the contacts. It's right here at the bottom. And KM1 controls these set of contacts. Questions so far? This is the lubricating pump system. So we have Q131, which is a 0.5 amp breaker. Goes to W20, which is an 18 American wire gauge. And K3, which when it needs to lubricate, K3 will then send a signal to the relay, and that'll close the contacts, and the pump will run to supply lubrication to all the clamp end of the machine.
Dave, question for you. About 5 minutes ago, you had talked about 3 extra receptacles totaling up to 39 amps, where each was 13 amps. And I missed that a little bit, and I want to have you reiterate. Is that something that is standard on the machines, and you just have to add the receptacle?
Correct. Yeah, that is a standard right on the back of the machine. If you look, there's a black box. It's usually right under the injection unit. And it has 4 little covers on it. I mean, 3 little covers, I'm sorry. So you could take this cover, the whole cover off here. And inside there's a terminal strip. The terminal strip actually is going to have line 1, line 2, and line 3, and the ground. So you can, hold on one second.
And are these duplex sockets?
They're 3-phase sockets.
Okay.
So inside the box, you'll have a terminal strip. You'll have line 1, line 1. Then you'll have line 2. Then you have line 3, and then you'll have your ground. So you pick one wire from line 1, 2, and 3, and then your ground, and you can have a 3-phase circuit. But again, keep in mind that's not included in the full load amperage of the machine. So if your machine full load amperage is 40 amps, you have to add another 39. So it'd be actually an 80 amp full load on the machine.
Yeah, so your drop has to be adequate for that.
Your drop, your wire size, everything. Yeah. What I do is, like, if I'm going to a show, what I do is I take these sockets, because some I'll run a chiller. Chiller will probably be 30 amps, and I'll put on a thermolator, or maybe a hot runner box, and the hot runner box may be 30 amps. And so what I do is I change the wires. I'll just take these wires all out, and I'll put a bigger breaker in here. Mm-hmm. And I'll change all of these wires out, and I'll just run these wires right to the side of the machine rail, where I'll put the outlets right on the machine rail.
Got it.
So you can do it either way. I mean, but again, you got to make sure that you have an adequate feed and the wire sizes are correct, because the wire size goes by the amperage of whatever device you're running.
Sure.
You don't want to have the wires start burning up on you.
Right. Thank you.
Yep. This is the front panel of the machine. This just goes through and shows you the wiring diagram for the front panel and where all the connectors connect to. So you have a K-can, your liquid crystal display, your display driver, and your communications to the keypad, and that all gets tied into the cable. The only difference to this is the 4030 machines. If you guys, anybody has an older 4030 machines, the actual CPU is located behind the screen itself. And so all the connections are done inside the screen, and there's only one wire going from the CPU to the it's not even a CPU inside the cabinet. They're just a bunch of IOs. So you have one connector going to the IOs inside the cabinet. This is the thermocouple layout. Again, the thermocouples are K thermocouples. If you use anything other than K, you can change it inside the controller to J or whatever other thermocouple you want to use. But K is the most accurate and has a higher temperature zone ratings. And I highly recommend using just Ks. And what they have here is they actually tell you the size of the wire for the thermocouple. So if you look, you'll see that TC00 is 4 meters long. TC01 is 2.3 meters long. TC02 is 2.5 meters long. Then you have 2 meters, 1.5, and 1.5. And again, your hopper check is 4 millimeters. Analog input module. Again, this is where all your positions are, your tempersonic rods. So you have a U reference, you have a analog input 0, and then you have your ground. If anybody's curious how these work, it's just a variable resistor. The voltage range is 0 to 10 volts. And what happens as the transducer moves back and forth, it varies the resistance. When you vary the resistance and put a voltage to it, the voltage changes coming out of the other end. So when it reads the voltage, it's actually reading a different voltage in between 0 and 10. These are analog signals. An analog signal is anything that has a range 0 to 10. A digital signal is anything that has 0 on or off status. That's it. There's no other status between for digital except for on and off. For example, when you turn a light on, that's a digital signal. It only goes on and off unless you're having a dimmer, which would be analog. Again, you have your injection pressure sensor if you need one. Some people have an injection pressure sensor also. That's an option. And also position's an option. Otherwise, if you don't have the nozzle position sensor, what you do is you set that limit switch so the machine knows when it's at 0 position, and it allows the machine to start injecting. Other analog inputs. This is for your amplifier card for your back pressure proportional valve. And this is your digital inputs. So all your inputs are here. You have your carriage forward, which is an option, oil filter status, oil level, your screw rotate sensor. And over here you have your rear door closed, emergency stop, front door closed, safety gate nozzle, hydraulic safety, mold completely closed, ejector back, mold adjust sensor, enough lubrication pressure, and your core in. Down here you have your mold completely closed signal and your front door closed signal. Now, to reiterate, you have your rear door closed and your front door closed and your e-stop. As I mentioned yesterday with the pills, you have 2 signals on the pills that also have the rear door closed, the e-stop, and the front door closed. Each door has 3 limit switches on them. So one limit switch will control this. The other 2 limit switches will go to the pills to make sure that the safeties are active. Same with the e-stop and same with the front door. This is for your cores again, core in, core out. Mechanical drop bar. Your mold area free for your robot. Robot mold close enable. Robot operation mode, whether it's in automatic or manual. Robot safety relay. Robot ejector forward and robot ejector back enable. Again, these are inputs coming from the robot. And you have your robot core in and your robot core out. As I mentioned yesterday, you get to select, or Tuesday, you get to select which core you want the robot to operate off of. So you just have to select core 1, 2, 3, 4, 5, or A, B, C, D, E, or whatever core you want the robot to function off of. And all it does is takes this signal and assigns it that core number. As you'll see, it's nothing specific. It doesn't say core 1N or robot core 2N or robot core 3N. It just says robot core in, robot core out.
Hey, Dave, is that an E12 signal?
Yes.
Or SPI versus?
They're both Euromap and SPI. There's not much difference between Euromap and SPI.
When you go to E6, E7, I think that provides the second core signal on the interface. Does that change this?
Nope. It'll have another core on here. This machine only has a Euromap 12 on it, so it only has the one.
Thank you.
You have your rear door close input, your rear door, front door close, your fixed door, which is the big door in the back of the machine. Not all machines have a fixed door. Photo sensor for your part drop. Limit for min mold height, limits for max mold height. Your air pressure check. When you ever get a air pressure check error, it's going to say no gas. It doesn't say air, it says gas, just in case anybody ever gets that error. If you have a servo alarm, that's the input that you're going to get from the servo alarm. Again, it doesn't tell you what exactly the servo alarm is. It's just going to tell you, hey, there's a problem with the servo system. Lubrication oil check is an input. Outputs. So you have your injection valve. Again, if you'll notice, you have KA8. KA8 is your safety from your pills. So the relays that are on the right side of the pills are your KA8, KA9, KA10 relays, and some machines have more. But if those relays are not activated, then obviously you cannot inject, you cannot charge, you cannot move your carriage forward, nothing will function. So the injection valve controls this KX2, and again, these are the 2 relays contacts that it's going to close or open. Suck back is D101, which is a hydraulic valve. Charge is D102, which is your hydraulic valve. Nozzle forward is D103, which is again a hydraulic valve, and your nozzle back is D104. Hold release, it's going to be D100 and D100.1. And you have your cooling oil and your feed cooling, which is your feed throat temperature. And you have your mold close valve, mold close fast valve, mold close, mold open valve, mold open slow, ejector forward, ejector back, core 1 in, core 1 out, mold adjust forward, mold adjust back, core 2 in, core 2 out. I forgot to mention these numbers right here and up here. Those are the actual wire numbers. So if you're looking for a wire, just look at the drawings and you'll see that C200 is for the mold close valve. C201 is for your mold close fast valve, and etc. Here's your central lubrication signal, your red alarm light, your yellow alarm light, your green alarm light, and your air valve 1, which is your air blow. Air valve 2, air valve 3, air valve 4, and if you have valve gates, then you'll have your optional valve gate signals. Now, what I would like to show you one really quickly, let me see. Give me 1 second here. I think it's on day 1. Sometimes these blueprints are generic and they don't always reference the correct locations and wire numbers. But if you were to look at this, the I/O monitor on the screen, it shows you your digital inputs. So digital input 0 is your nozzle limit switch forward. Digital input 1 is your oil filter check. Digital input 2 is your oil level check. Now, these, it may or may not match up to the blueprint, but these are true locations of where they are located on your inputs. If you have any expansion modules, you have your expansion, there's 2 analog modules on this one. These are loaded at startup and are assigned by the software and are the actual values of where the locations are on the inputs and outputs. So if you would scroll down here, I couldn't do it on this one because it's just a picture, but if you scroll down, you'll see all your outputs. Then, you go to your analogs pages and you can see all your analog signals, the keypad, your LEDs, all of that stuff. These are loaded again when the software loads at boot up. So it is these values or these locations for your inputs and outputs can never be wrong. So if you have a problem trying to find something, let's say you couldn't see where your mold close signal, you're looking for this guy. So all you have to do is go to your input. So there'd be this mold close would be DI09. And that's all you have to look at. So if you don't rely, if you can't rely 100% on the blueprint, because sometimes those blueprints are pretty generic. They're for every machine they make out in the industry. So if they're really generic, it's always good to reference the I/O monitor page. Because these values, again, cannot be wrong. These have to be the exact values that the machine's referencing. Questions on that? All right, continue. Again, you have your SSRs for your heat band heater circuits. So you have your heat 1, 2, 3, 4, 5. Sometimes they do give you extra heater locations, and they do give you an extra SSR on most machines, not 100% all of them. What you can do is, I usually do it on some startups and stuff, is if a customer has a for example, a hot sprue, you can actually wire that into like heater 6. So you just use your inputs, go to the SSR, change the voltage, obviously, to 220 volts, tap off the transformer or put a new transformer in there for 220 volts, and you can use heat 6 as your hot sprue. And it will be controlled with the controller because it also has the input from the analog input. You just connect that to the heater 6 input, and it'll read the temperature, and it should be good to go. Again, this is the motor off circuit, your motor on circuit, your heater on circuit, your motor on command, your J5 cooling motor, robot mold open, robot auto mode, and robot reject. These are outputs to the robot, these three. Again, you have your robot eject back, your robot eject forward, robot enable core in, robot enable core out. The newer machines, since I believe 2012, somewhere around 2012, 2013, 14, they actually started adding an RJG circuit outputs signals. So if you have an RJG system, there should be a terminal block TB10 that has all your RJG signals that you can just hook up to your RJG system, and everything that you need for signals should be there. So you have your screw rotate, your injection forward, your mold clamp, your mold open, first stage inject, second stage inject, your manual mode, bad parts, transfer based on external signal, hydraulic pressure, your screw position, and your ground. Then it'll give you your analog signals up here, your injection stages, all manual mode, automatic mode, second stage inject. And we covered this yesterday, the pill safety relay. Does anybody want to cover this again that wasn't here yesterday? No? Okay, we'll move on then. This is your Euromap 12 interface. I believe most of the machines are going to start coming in Euromap 67. The only difference between Euromap 12 and 67 is this one's a 32-pin connector, for one thing. 67 is a 50-pin connector. These have two rows. The 32-pin has two rows of connection points. The 50-pin has 3 rows per input and output. The 50 Euromap 67 has dual channel e-stops and dual channel safety door signals, whereas the Euromap 12 only has single door stop and e-stop, door signals and e-stop signals. So this is signals from the robot to the machine, and these are from the machine to the robot. And this is just a relay contact information block. At the end of the manual, you'll have your part list. So you have what the part is, quantity, a description, model number, your manufacturer, and part number. The part number are the high TN. These are high TN part numbers. So if you're looking for a part, what you have to do is take a picture of the part, take a picture of the nameplate, look up the part number, and send that to the parts department, and they will look up and find you the part that you need. Now, on the hydraulic section, we actually give you the actual valve numbers and cross-reference two of the valves. So if you want to look at, if you want to buy a Rexroth valve from Rexroth, you can. Or if you want to substitute Rexroth for another manufacturer, we give you the cross-reference numbers also. And that'll conclude the blueprint reading for the electrical. Now we'll do the hydraulic blueprints. Sorry. If I can find them, sorry. They may be in here. I believe they're in day 2. Yes, here they are. So the hydraulic blueprints, again, you have a lot of symbols. You have a symbol for a single hydraulic piston rod cylinder, a bidirectional hydraulic die-height motor, a unidirectional hydraulic screw motor, hydraulic pressure transducer, hydraulic proportional relief valve, hydraulic safety valve. This is the diagram for a solenoid operated directional control valve, 4-port 2-position with spring return. Then you have a solenoid operated directional control valve, 4-port 3-position block center with a return, spring return. And the proportional directional control valve, which is 4-port 3-position block center and spring return. And your pilot operated directional control valve, which is a 4-port 2-position. And you have your solenoid operated directional valve with slave. Master is a 4-port 3-position with a field-safe center spring return. And the slave is a 4-port 3-position block center spring return. You have a standard cartridge valve, spring loaded, office pocketed. Another cartridge valve that's just spring loaded. And then you have a solenoid operated check valve, spring return, servo driven hydraulic gear pump, manual pressure release valve, inline check valve, and a heat exchanger. Hydraulic pressure gauge, hydraulic high pressure filter, inline suction filter, hydraulic oil level. This is a manifold envelope. Then you have your hydraulic pressure work line, hydraulic pressure pilot line, hydraulic accumulator, inline flow control valve. Not all machines have an accumulator on them. Only the larger machines, I believe from MA 800 ton and up, will have an accumulator, and the accumulator is for the clamp, to give it extra oil for the clamp open and close. The hydraulics on this machine is pretty simple. We usually use just control directional valves. So for example, we give a test. Let's say you wanted to know, wanted to check to see if the suckback was a problem. So you look over here, suckback is using valve number D101. So whenever there's suckback, you look for D101 on your injection. It's right here. And what'll happen is that'll shift over that way. And the ports will cross, so it'll go this way and that way. So the oil will flow up, go up through here, push the cylinder back, then it'll go here to tank, go down the tank. There's nothing really difficult on any of these hydraulics on the machine because they do just use directional valves. It's just a matter of reading the symbols, finding the valve that's being activated, and follow the direction of the arrows. So the arrows will show you which way the oil is flowing. This is your safety door for your hydraulic safety that's in the back of the machine. There's about, I believe there's 2 or 3 different hydraulic safety valves on these machines. They used to have a little walker switch on the back of the door, which actually opened and closed the valve themselves. Then they went to an electronic system where when you open the door, the electronics kick out, which shuts the valve for the hydraulic safety for the rear half of the machine, which would control the clamp section and mold height and your ejectors also. Again, this map, what it does, it just tells you which valve is being energized during which action, whatever action you request. Here's at the end of the hydraulic prints is the component list. So these are what is on the machine actually. And if you keep going, we'll get to that in a minute. It'll actually give you the cross-reference. So if you want anything other than Rexroth or any others, it'll give you your Vickers number, it'll give you a Rexroth number or any other different manufacturer. We do give you the entire number. We do not give you just partial numbers. So when you're looking up your hydraulics, you can call Rexroth. You can say, okay, I need valve number DB10-2-5X/200, and they'll have that in stock, hopefully. The difference between going through Rexroth or Vickers and going through us is we only have a 5% markup, which covers our cost. So, and we get volume discounts from the factory. So we actually get the valves from the factory, which sells 30,000 machines a year, and some of these machines have multiple valves on them. So I think having 10 or 15 valves per machine at 30,000 machines a year, I think we have the industry pretty tight as far as getting volume discounts. So again, we always sell parts at a less price than you can get from Rexroth or Vickers. This section shows you the manifold where all the valves are located and the ports. This is your injection manifold. This is your ejector manifold and your cores. Clamp valve manifold. And that's it. Any questions on anything from today?